Alrighty, so for my midterm project, I did the planning phase just in GIMP. I created a little short list of what I had planned out and what I wanted to achieve for this project. So I just went in order of what I thought would be built first, which was just set out the objective first, then get the basic idea of what the mechanics are going to be, which was in this case just take what we did during the two projects leading up to the midterm and then just incorporate it into the midterm project. Then planning out what level 1 was going to look like and how many enemies were going to be there. Level 2, same process there. Then the gameplay mechanics were what I was planning to do. Not all of this worked out, unfortunately, but some of it did, which is good. Then we had the UI, which was just what I wanted to have appear on the player screen. And then the audio I was able to get in there after some difficulties, but that was all imported and is set up in the scene. Alrighty, and for imported assets, we have the stuff I created myself. We have the lampposts, the well, sword, shield, that kind of stuff from the last few projects. Then from the marketplace, we got some foliage, the trees and the grass, and added the castle walls as well. And I included some music and sound effects. These sound effects are for the player attacks. And we have some music, this one that a friend of mine made, and some additional music for level 2. And the same story here, we use some Unreal assets from the marketplace and just sprinkled them around in the scene to add a little bit of life to it. Alrighty, for the principles of OOP, we have abstraction. Abstraction is basically just hiding information that other coders don't necessarily need to know. They just need to know that if this character or if this event happens, this is the outcome. So for example of that, we have heal, which this is just a function in the health component. So all that anyone will see when they actually need to do something with this in the event graph, they will just see heal. All the actual code for doing that is hidden away in the function. For a polymorphism is just basically having different ways of doing something, but they have the same name. So the example given in class is there are multiple ways to open something depending on what it is. Like opening a door means something different from opening someone's heart, opening their mind, that kind of thing. We don't have any examples of that in this project at this time. For encapsulation is just basically putting all of the information you will require inside of one area. So an example of that would be the player attack. So basically all of the core functionality for player attacks is right inside of this. So we have this event will occur when it hits, whatever the actual attack is. When it hits, it will check to see if it is the valid enemy type, and then it will spawn these effects. And for inheritance, again, we have player attacks. Player attacks is the parent actor. It has all the information that a player will need to launch a projectile or attack an enemy, and it can be used in all child actors. So example, the fireball child actor. We got the core code from the player attack base, and then we can add on to it as we need to. Alright, so we use variables in a few different places in the project. We use them mostly in the game instance. So basically how we use variables in this project is we have player lives, total score, and their score. These are all exposed variables, so I can edit them as I need to. So let's say like I wanted to change the player score when they get into a level, or a specific level of the game. I could use the total score because it is an exposed variable, and I could change that on the level. Same thing with the player lives. Alrighty, and for frame rate dependent, or rather time dependent, we have the same example from last class. We have the vector math formula. So we turn this delta seconds, which will change the game from going by frame rate, which is it'll call this action every frame rather than every second, which can become it can become a little glitchy or not work as intended when you have a lower frame rate or an extremely high frame rate. So then just doing this simple math formula will turn it from every frame to every second instead. Alrighty, for load-in levels we have functionality for that. That's actually in the game instance. So the game primarily loads from level 1 to level 2 with the main menu, victory, and game over screens in between. So it's entirely dependent on the player score. So the total score is added to every time an enemy gets destroyed. It will add 1 point to the total score whenever this event is called. If the number is equal to 10, it will spawn a level 1 end goal actor, which the player will need to walk into. And I set up this code just because we were having a few errors, but this is now actually redundant. If that is false and the player does not actually have equal to 10 points, it'll move down here, and if it is greater than or equal to 25 points, the total score, it will open the victory level. So this is how I decided to go about changing the levels. You can also just do it as open level as down here, but I wanted to have the player actually walk to proceed to the next level. Alrighty, so we use the game instance to store certain information that we want to keep across the entire game. So example, we have player lives, and we have the total score of the player. We want that information to stay the same across the entire game, no matter what level you're on. Most of the information we needed for this game is inside of the game instance, but we do have some game mode specific information. Let me go get it. It's in third person, blueprints, game mode. Yeah, so for example, we have certain functionality that's just in the main menu. So create the main menu widget, add the viewport, show cursor, that sort of information. So that's the core game logic of the main menu. You just need to be able to have your cursor and see the UI to be able to progress. And for the singleton pattern, that is just having only one thing of a specific value, so you won't have to specify what it is at any point. An example of that is right here. It's the player controller. We only have one player controller, so there's no need to specify anything more than player index 0. Alright, for collision hit events, we have the player attack base. So basically just every time the component will hit something, it'll call the projectile hit. It'll make sure it's the correct player, in this case the enemy, and it will destroy itself and cause an explosion. For overlap events, we have the enemy, which is event actor begin overlap. It will, if it's overlapping the player, it will cause damage to the player, but it will also destroy itself. This is how the lightning AoE attack works. The lightning AoE is just a collision box and a particle effect, but whenever one of the enemies overlaps the collision box for the lightning effect, it will destroy them. Alrighty, for input keys, we have the left mouse button here, which just spawns the fireball actor and gets the information for where to shoot it. And same thing down here with the right mouse button. Press the button and it will create the lightning AoE effect on the player location. Now the difference between a key event, like these two right here, and a is input key down would basically be, as far as I understand it, it is for a left mouse button, for a key event, we are just pressing the button and the action is occurring. Nothing happens when released. Is input key down is going to make sure that is the input key staying down and what will happen if it is released. So an example of that would be like a crouch mechanic. You hold control, is input key down, then the player will crouch. But when you release it, they will stand back up. For custom events, we have a few different ones throughout the project. We have the player score custom event, which just keeps track of the score of the player and how it is in relation to actually progressing through the game. And for different functions we have during the gameplay, I believe we have some that are right here in health. Yep, we have the functionality, or the functions rather, for just updating the health of basically everything, and then all the child actors, including the functions of these as well. So we have the functionality for taking damage, healing, dying, and updating UI. And this basically contains all the information that is required for any healing in the game stored within this one component. For our user interface this time around, we have a little bit more information. We have the health of the player, which now has a progress bar that works. It is actually going to be full when the UI spawns, rather than what it was before, which was just gray, and then the blue bar would show up after you take damage. That's been fixed, and the score and the lives are also updated in real time. The functionality for that is here in get score text and get score lives, or get lives text rather. And I'll go ahead and show that in the game real quick here. There we go. Right now, score is 4, lives is 3, and as we kill the character. Alrighty, and this is just a little addendum because I forgot to go over this information when I was recording the original video. For vector movement and how we use that to move certain objects in the game, we have functionality for that in the enemy blueprint. How movement here works is we get the player pawn, and then we get the location of that pawn. We subtract it from where the actor is, in this case the enemy. We normalize that value. Then this is for the time stuff, but after we normalize the value, we get the difference between where the enemy is and where the player is. Then we get the location of where the enemy is again. We add those two values together, and then we set actual location to the difference. And this is updated every second, so it is always heading towards the player location. Alrighty, and we have the finished build of the game. We have the main menu here. You no longer need to hit the Windows key to be able to open it. Sorry if these sounds are a little loud, they are on my end at least. The functionality is all here. The fireballs work, the lightning works, and you can progress when you reach the final level. I have noticed there's a bug with the fireballs where for some reason they stop actually moving, but they work as a mine, so it's still somewhat working. But yeah, so that's the midterm project. I'm really happy with how it turned out.